Alright, you guys, so let's figure out how we're going to solve it. Alright, so we already know what it means. We got to find values of x and y that when I plug them into both equations, I get true statements. So how do we go about solving this? And it turns out that graphing, all that stuff we did in chapter 3 is going to help us out here. Because remember what a graph represents, right? It's a visual representation, right, of all solutions to an equation. Right? That's what it means to be a graph. It's a visual representation of all the solutions to an equation. So that means x plus y equals 10. If we can graph this, we would get a picture of all the ordered pairs that solve that guy. And of course, since this is another equation, this will be another graph. And of course, it would consist of all the ordered pairs that solve that. And then hopefully you guys can kind of start to visualize, if I can draw this picture and I can draw this picture, right, I'm basically looking for where do those two lines cross. And wherever they cross, that's the solution point that solves both. There's my system to that equation. So that's basically what we're going to do. So how do we solve this? Well, again, you can point plot, use x-intercepts. How about we just use good old y equals mx plus b? And so in here I would subtract x from both sides, and that would give us y equals negative x plus 10. So this is telling me that my slope is negative 1. You can write that as negative 1 over 1. And my y-intercept is at 0, 10. So I can go over to my grid. Should have probably drawn that earlier, although I guess I didn't want to tip my hat. What we're going to do, okay, I'll go over to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so, oops, I'm in the wrong direction, am I not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'll start going down 1 and over 1. Down and over 1. Down and over 1. Down and over 1. Down and over 1. So you guys can kind of see what I was doing. In my head, I was drawing the x-intercept. Okay, so let me kind of put that over to the side there. So again, here's all the solutions, right? This is everything that solves x plus y equals to 10. All right, we're visualizing all the solutions, and it goes on forever. So what about the other graph? Well, if we also put that in slope-intercept form, we get negative y equals negative x plus 6. If we divide everybody by negative 1, we get y equals x minus 6. So this is telling us our slope is 1, or 1 over 1, and our y-intercept is at 0, negative 6. So if I go plot this, 1, 2, 3, 4, 5, 0, 0, negative 6, and the slope is telling me to go up 1 and over 1. Up 1 and over 1, 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 up 1 and over 1. And if we keep following that pattern, right, so again, what I have there is all the solutions to x plus y equals 6. So I see all the solutions for one equation, I see all the solutions for the other, and lo and behold, they are intersecting. And it looks like they're intersecting at, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So it looks like the x-coordinate is 8, and it looks like the y-coordinate is 2. And there's your solution. How do I check to see if that is the solution? Plug it in, right? 8 plus 2 is 10, check. And 8 minus 2 is 6, check. So there's our solution. We can also see, because of the graph, that's the only solution. There's only one value that will make both equations true. So the picture is kind of showing us not only what the solution is, but it's also showing that nothing else will work. That we only have one combination, 8 and 2. So there's your strategy. So to solve a system, one way that we can solve it is by graphing both equations and then seeing where those lines intersect. And that's going to be our strategy. So we'll see it in practice in some future videos.